AP Calculus BC, Unit 7, Day 8, Office Hours. These are the answers. You can check them, pause the video real quick. Pause the video if you need to check these. Here's the next page. These are all graphing calculator allowed problems. I gotta show you your setups though. Here's the next page. And here's the last one. Okay. So let's try these out. So this first problem just says to evaluate it. So just can you type things into your calculator correctly? Math 9, cosine, I put parentheses around it, 3x close squared plus 2e to the negative x, comma x, comma 1, comma 1.5. There we go. So 0.597 through decimal accuracy, rounded or truncated for your final answers. Okay, number 2, find the area of the region close by, y equals 2 cosine x and y equals x squared plus 1. So we should probably draw a picture of this. Parabola, shifted down 1, cosine curve with an amplitude of 2. So the period is 2 pi. Cosines up here, here, here. So this is your cosine curve. Parabola shifted down 1, over 1, up 1, but that's not 1. That's pi over 2, so that's like 1.7. So 1 would be kind of like more right here. So it's going to look, I don't know, something like this. So one thing we're going to need to do on our calculator, because I don't think solving by hand will work, is find the intersection points. So should be something you guys should be able to do. I'm going to type these into my calculator. So 2 cosine x, make sure you're in radian mode. You have trig, x squared minus 1. Window, I think -3 to 3, -2 to 4 looks good. So here's your cosine curve. And there is your parabola. So we're going to find these two intersections. It looks symmetric, so probably just find one, but I'll probably just do them both. Number 5, intersect, first curve, second curve. Guess 1.2654237, 0.60129716. Carry more decimals than 3. Second, calculate. Number 5, intersect, first curve, second curve, -1 for my guess. There it is, -1.2654224, comma 0.60129716. Definitely looks symmetric. Okay, so now we're going to set up region, and we're going to do y top minus y bottom. We could take advantage of the symmetry and just do half and then double it, but we are going to use our calculator. So the area is integral y top is the parabola x squared minus 1 minus y bottom is the cosine curve, 2 cosine x. You need parentheses around it, dx -1.265424 to positive 1.265427. Show your setup. I'm going to put this in our calculator. Now I'm going to go ahead and take advantage. I'm not going to do the integrals on here because I'd only be able to do one at a time. I'm going to do them on here, math 9, but I'm going to go ahead and say, I mean, we could do vars, y vars function y2 minus vars, y vars function y1. If you got the order wrong, it'd be obvious because you get a negative answer. Negative 1.265,424, comma 1.265,4237. Negative 4. See, I did it wrong because I got a negative answer. So I wrote this correctly, but when I enter them in here, the cosine was first. That should be second. I don't know. I thought I did it right. No, the cosine should be first. So I wrote it wrong here. It should be 2 cosine x. That one's on top, minus x squared minus 1. So I'm not going to just fake it. I'm going to go back here and do vars, y vars function y1 minus vars, y vars function y2, and do it the right way. So positive 4.994 or 4.995. Round or truncated. There's your answer. On my work online, I write a lot of extra notes about like what buttons to push. That's not something you have to write on a test or assignment, but it could be good notes for yourself. Now, this one's interesting. If we want to, let's see, solve this problem, let's see. So let's see. All right. Now we're trying to solve for A. So what you usually need to do is you would actually integrate these. This one we could actually integrate and get a number for, but the antiderivative of an exponential is itself, just like e with base e, but then you have to divide by the natural log of the base because the derivative would have a natural log of the base. So you got to kind of counter it. And it'd be 0 to 1,000 minus same thing, 8 to the x, natural log of 8. A to 1,000 equals 10.4. Plug 1,000 in, 8 to 1,000 power. Wow. Natural log of 8 minus 8 to the 0. Natural log of 8, which is not 0, it's 1. Minus 8 to the power of 1,000. Natural log of 8 minus 8 to the power of a. Natural log of 8 equals 10.4. So these cancel each other out. And so, and we got to distribute this. So we have 8 to the a, natural log of 8. And I would move this to the other side plus natural log, 1 over natural log of 8. Multiply by natural log of 8. Distribute. So we have 8a, 10.4, natural log of 8 plus 1. Now, how do you solve an exponential? Well, take the natural log of both sides and use the rules of exponents to move this out in front as a coefficient, and then you divide both sides by natural log of 8. So this is your exact answer. I didn't even use a calculator, but we could use our calculator now to figure out what this value is. So let's see, natural log of 10.4, natural log of 8 close plus 1 close divided by natural log of 8 is 1.499 or 1.500. You round. Now, the interesting thing here is if you tried to, like, we didn't have to integrate this by hand. We could have just put that in our calculator. We could have just said, you know, this one we have to integrate. Like this one, we have to do this. This one we could have just done on our calculator. So if we said math 9, 8 to the x, comma x, comma 0, comma 1000. Ooh, error, overflow. What that means is the number, the value of that is too big for the calculator to handle. Now, when we did it by hand, those huge terms canceled each other out before we even tried to calculate them. So anyways, that's what error overflow means. It's like too big of a number. Okay, next one, find the enclosed area, and then if 2/3 of the area enclosed is below, so 2/3, 1/3, so find the value of y equals k, that cuts it that way. So we first should find the area. Now, we are going to have to do the second part with a horizontal slicing for sure. So the first part you could do with horizontal slicing or not. We got to, this y equals, this is at 2, 0. And this, let's see, are they telling us what that value should be? Oh, when do these intersect each other? Square root of x equals x minus 2. Square both sides. You can use your calculator to find this intersection, but it might be quicker to just do it by hand. It's pretty simple algebra. So x equals 1 and 4. Now there's two answers because you get the same thing if this parabola went over here. This is the 1, and this one right here is at 4. So you got to kind of know what's going on. So it's 4, but you could use your calculator. So this is at 4, comma 2. Anyways, if you want to find this area, you could do vertical slices. You could do this whole area and then subtract this area. You could calculate it as a triangle if you want. You could say, all right, 0 to 4 of the square root of x dx minus 1/2 base times height. Do it like that. Math 9, square root x, comma 0, comma 4. Minus 2. So we get, let's see, 3.333333544. So you could do that. We could have started with horizontal slicing, which we're going to have to do for the next part. It'd be 0 to 2, horizontal slice, x right minus x left. X right in terms of y is y plus 2. X left is y squared dy. So we could do it like that. Let's see if it gives us the same answer. Math 9, x plus 2 minus x squared, comma x. We put x's in for the y's. That's the only variable we have. Hey, same answer. Close. Almost the same answer. This one just has lots of 3's. Yeah. So, I mean, the different it's using an estimation technique. So if you make it slice it a little differently, it can give you a little different answer. So, or you could have did it by hand. It looks like the answer should have been 3 1/3 exactly. But use your calculator. Your work should reflect that. Now, what we want to do is we want to take horizontal slices. So that's why doing this for first part might have been beneficial because you're going to have to do it anyways. And we're going to go 0 to k or k to 2. I always like to go 0 to k. And it should be 2/3 of this area. Whichever one you did. And then we will have to integrate this by hand. Y squared over 2 plus 2y minus y cubed over 3 equals. Now, we still have the limits. So we could do I'm just going to go back to that other answer. Okay. And times 2/3. We get a 2.222222362. All right, now we plug k in. So it's going to be 1/2 k squared plus 2k minus 1/3 k cubed. Plug zeros in, that's all 0. So now we got to solve this equation, which I don't think you want to do by hand. So we're going to use our calculator, and the best way to solve an equation on your calculator is move everything on one side equals 0, like you would anyways if you were solving by hand. Equal to 0. Graph it and find its x-intercepts. That's the best way to do it. So I'm going to go here. I'm going to graph it, 0.5. I'm going to put x's in for the k's, x squared plus 2x minus x to the third divided by 3 minus 2.222222362. I'm going to go to the window, and I expect the answer to be between 0 and 2. It's a y value. It's got to be 0 to 2. All I care about is seeing the x-intercept. So I'm just going to set that y min and y max the -1 to 1 so I can just focus on the x-axis. I think we should only get one answer. There it is, really close to the middle. So then we do second calculate 0. And we say, well, it's between -5. Oops, didn't like that. I put -5, meant to put -0.5. If you put a value outside the window, it's going to give you an error. -0.5. Okay, what did I do again? Oh. Okay, I'm going to say 0.5 to 1.5, guess 1. And that's the answer. K equals 1.027, 3 decimal accuracy, or K equals 1.028 if you want to round it instead of truncate. So that involved a bunch of different good skills on your graphing calculator. Number 5, find the area of A, and then B. So A, I would just do vertical slices yt, y top minus y bottom. So we're going to integrate. We do need to find these values, I think. Plug 0 in here, you get 0, 1. Plug 0 into here, you get 6. This intersection we're going to need to find from a graphing calculator. So go here to y, graph these two equations, e to the x and -2x plus 6. Go to window. This x-intercept right here is at 3, so that gives you a good idea of what your window should be. So probably like 0 to 4, we can say -1 to 4, -1 to 7 to get a good graph. So there's our intercept that we want. Second calc, intersect, first curve, second curve, guess. There it is. I'm going to put it on the graph. 1.2517579, comma 3.4964841. Okay, so our limits, we're going to go left to right, 0 to 1.2517579. Y top is the line, -2x plus 6. Y bottom is the exponential, minus e to the x dx. That's our setup. And put in our calculator. I wouldn't do it from the graph screen because if you want to do multiple functions at the same time, you can't. So I'm going to do it here. Math 9, -2x plus 6 minus e to the x, comma x, comma 0, comma 1.2517579. And we get 3.447165532. So the answer, final answer, 3.447. Okay, B, you're going to have to break it into two sections, vertical slices. So we're going to have to do 0 to 1.2517579. And then that's just the area under that curve, e to the x, plus 1.2517579 to 3 underneath the line, -2x plus 6. You could do the area of a triangle for that, but I don't know. It probably seems easier just to let your calculator integrate it. So that's your setup. Excuse me. So we're going to do math 9, e to the x, comma, x, comma, 0, comma, 1.2517579 plus math 9, -2x plus 6, comma, x, comma, 1.2517579, comma, 3. And that would be 5.552 or 5.553 if you want to round. So there you go. Should be good at finding area. We got some volume by cross-section problems. So first one. Base of solid is enclosed by this function, the coordinate axis. Now, you could use your graphing calculator to help you graph this, but if you are good at your basic shapes, this is a parabola that's been shifted to the right 2 and exaggerated by 3. So if you plug 0 in here, you're going to get 12. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 1, 2, 3, 4. 1, 2, 3, 4, 5. Okay, so it's been shifted to the right 2 units. Up 1 over 1, but now it's going to be 3. Up 2 over 4, but now it's going to be 12. On this side, it's going to be 3. This side is going to be 12. So this is your parabola. So it says this in the coordinate axis. So this right here is your base region. And the cross sections are perpendicular to the x-axis. So they're straight up and down, and they are half circles. So my picture isn't that great, but hopefully it's good enough for me to get the job done. So the volume by cross section means, since they're vertical slices, they should be a function of x. And in this case, they are half circles. I like to just draw a simple picture. And then that's going to be 1/2 pi r squared dx. I like to just write the most generic function. And then we can move the pi over 2 out front. The limits are going to be 0 to 2. Now the radius, this is the diameter. The diameter equals y top minus y bottom, and y bottom is 0. Y top is that curve. So it's going to be the y value divided by 2 squared. So then you have to square the divided by 2, so you can move that out front. Pi over 8, 0 to 2. The y value, though, needs to be in terms of x because we're trying to integrate with respect to x. So we're going to replace it 3x minus 2 squared. Now, that's good enough for your setup. We could simplify it. 9 pi over 8 x minus 2 to the 4th. Little easier to type in your calculator, but let's type that in our calculator. So 9 pi over 8, math 9, parentheses, x minus 2 to the 4th, comma, x, comma, 0, comma, 2. And that's your answer. 22.619. There you go. Okay. Here's another one. Base of solid is enclosed by this this function, the square root of sine, that is from 0 to pi, which I think is important because you can't take the square root of negatives, right? So I think, if you were to just graph the sine curve on its own, it would look like this, right? Now we're going to take the square root of it, which is going to give values kind of like a hump like this, but then wouldn't exist over here because it's square root of negative, and then get multiplied by 2. So, I mean, it looks something like this. That's your base region, right? And then it says that the cross sections are perpendicular to x-axis, and they are equilateral squares topped with equilateral triangles. So they look like little houses with all equal sides. So our volume formula is some formula for area in terms of x. It's a square plus an equilateral triangle. That's going to be side squared plus root 3 over 4 side squared if you've memorized the equation of the area of an equilateral triangle. If not, it's pretty easy to develop because all the angles are equal, so they've got to all be 60. You draw the height in, it splits that into 30 and 30. You have side, side, side. This is going to be side over 2. 30, 60, 90. The long leg is the short leg times root 3, so it's s root 3 over 2. And the area of a triangle is 1/2 base times height. The base is s, the height is s root 3 over 2, and we get root 3 over 4s squared for the area of an equilateral triangle. So, I mean, if you had to, you do that yourself. Now, the limits are going to be 0 to pi. We do need to get the sides of the square and the triangle somehow in terms of, it's going to be y top minus y bottom. It's going to be the y values. We could also factor the 1 plus root 3 over 4 out. But it's going to be the y values. But we need the y values in terms of x. So it's just y top, which is this function 2 square root of sine x squared. So we could clean this up a bit. Not that you have to. I mean, this could be your setup. But and this is a very reasonable problem to do by hand, but let's just use our calculator. So 1 plus square root of 3 over 4, close, math 9, 4 sine x, comma 0, comma pi, 11.464. Round truncated through decimal place actually comes out the same for both ways. So there we go. Got some solids of revolution. Find the volume of solid generated within the region enclosed by the x-axis, y-axis, inverse sine, and x equals 1 is revolved around the x-axis or around the line x equals 2. So we got to kind of sketch this. Do you guys remember what the inverse sine curve looks like? This is a sine curve, and it gets flipped across y equals x. So it ends up looking like this. But principal values tell you it's just this portion of the curve. Now it says y-axis, which is this, and then x equals 1, which is actually right there. Because that's the amplitude of sine, so that's going to be your domain. So there it is. We're going to revolve it around the x-axis first. So around the x-axis. So if you want to find that volume, I think you're well, this function is y equals inverse sine of x. If you're going to do vertical slices, which would be disks. You have pi r squared dx. And the limits would be 0 to 1. Your radius would be just the y value here. It would be inverse sine of x squared. The problem with this is, well, I don't know. You can't integrate this by hand, but we have a calculator, so I think it should be able to do it. Let's just try it real quick. And then we could try shells. I think shells would be more doable by hand, but pi, math 9, parentheses, inverse sine of x, close, squared, comma x, comma 0, comma 1. It's working hard. Okay, there you go. 1.468. So we could do it like that, or we could do parallel to the x rotation, which would be shells. So that'd be 2 pi r h dy. And the limits would be in the y direction, 0. This is pi over 2. 0 to pi over 2. The radius would be y. The height of the shell would be 1 minus this x coordinate in terms of y, which would actually be sine of y dy. So that's your setup with shells. And let's see if it gives us the same answer. 2 pi math 9 x parentheses 1 minus sine of x, close, comma x, comma 0, comma pi over 2. Hey, same answer. 1.468. Nice. Okay. Part B says around the line x equals 2, which would be over here, x equals 2, vertical line. And so it would look like this. And so if you want to do vertical slices, this time it would be shells. So for part B, if you can do vertical slices, it's going to be 2 pi RH dx. And the coordinates are going to be 0 to 1 in the x direction. The radius is going to be 2 minus whatever x coordinate we're at. 2 minus x. And the height is going to be y top minus y bottom. That's going to be inverse sine of x dx. So that's your setup for shells on part B, vertical slices. Put that in our calculator. Wouldn't be able to solve that by hand. 2 pi, math 9, parentheses 2 minus x, inverse sine of x, comma 0, comma 1. And this should give us a different answer than part A because it's a different shape now. 4.705. All right, let's try it the other way. So the other way would be it'd be a dishwasher actually, pi r squared dy minus pi r, little r squared dy. The limits would be in the y direction, 0 to pi over 2. So you're slicing it this way now, right? And the big radius is going to be 2 minus this x left in terms of y, which would be sine y. So it's going to be 2 minus sine y. 2 minus sine y. And then the little radius is going to be 2 minus 1 squared dy. So that's your setup for washers. And then let's calculate it on the calculator, see if we get the same decimal answer. So pi, math 9, parentheses 2 minus sine of x, close, squared, comma x, comma 0, comma pi over 2, minus pi, math 9, 1, comma x, comma 0, comma pi over 2. And let's see if we get the same answer. Hey, we get the same answer. It's always feels nice. All right. Did that problem two different ways. Okay, number 9 says the region enclosed by, we're trying to find solid root. That's a sideways square root, right? Line x equals -2, y equals x minus 2. So that's the y-intercept, and then the slope is 1 up 1 over 1 up 1 over 1 up 1 over 1 up 1 over 1. So it's going to look like that. And then we're going to revolve it around the y-axis for part A. So it's going to look like that. So if we're going to do vertical slices, I don't think I would do shells, but y top minus y bottom. I guess we could do it just for fun if you really want. Well, these are going to be shells. I just don't think I do dishwashers, but we get it. So we're parallel to the axis of rotation. So if we're going to find the volume, it's going to be 2 pi r h dx. So it's going to be 2 pi. The radius is whatever x value we're at. We got to find the intersection of these, which might be easier just to do by hand, set them equal to each other. So the 1 comes from the fact that you would get the bottom half. If you squared it, that'd be also a solution for there. So that's 1. This is 4, comma 2. So your coordinates are going to be 0 to 4 in the x direction. The height right here is y top minus y bottom. And y top is the square root of x, and y bottom is the x minus 2 line. So that's your setup. And then we could put it in our calculator. So 2 pi math 9 x parentheses square root of x close minus x plus 2, distribute the subtraction, close, comma x, comma 0, comma 4. And we get 46. Is this the right answer? I don't know. 46.914. 45019, just in case we need it for the second part. 46.914. Now, I'm looking at my solutions, just double checking. I get like 38. So did I type anything in wrong? Oh. Coordinate axis. It was supposed to just be this. That's the part that's getting revolved. So what we should do, we're going to have to split this up into different shells. So we're going to have shells there and shells there. So the volume would be 2 pi. The radius is just x, but we're going to go to this x-intercept, which is 2. So we're going to go 0 to 2. And the height of the shell is just the square root of x. And then we're going to go 2 to 4. The radius is x. The height of the shell is now square root of x minus 2. That's the setup. I just kind of left part of that out. So it's going to have the thing that we just did, but only 2 to 4. So I'm going to just reuse that. Plus 2 pi math 9 x to the 1.5 power, comma x, comma 0, comma 2. So I think this should, yeah, there we go. 38.536869778. Okay, 38.536 for your final answer through decimal accuracy, or 38.537. We could do disk washer method here, and this time now with the new drawing, it actually feels better. Pi r squared dy. You're gonna have to do vertical though. Pi little r squared dy. Integrate. Integrate in the y direction, so it's gonna be 0 to 2. The big radius is going to be the x coordinate here on the right in terms of y, so it's going to be y plus 2. And then little radius is going to be here, and x right is going to be, it's going to be this way. It's going to be y squared. So this should give us the same answer that we just got. Let's try it out. Pi math 9 parentheses x plus 2 squared comma x comma 0 comma 2 plus pi math 9 x to the 4th comma x comma 0 comma 2. Oh, I'm going too fast or something. I don't know. Didn't get the right answer. I don't know if I'm missing anything here. Oh, it's supposed to be minus. Minus. There we go. Okay. So part B says find K if the line y equals K revolved around the y-axis splits the volume into 2 equal parts. So there's some line y equals K that would cut this volume in half. I mean, what we want to do then is we definitely want to do the horizontal setup. So we definitely want to use this. But we're going to go 0 to K. So we're going to use the same thing. 0 to K. And then it should equal half of this area. We're going to actually have to integrate it by hand and then solve it on our calculator. So this is going to be y squared plus 4y plus 4. So the antiderivative is going to be y to the third over 3 plus 4y squared over 2 plus 4y, 0 to k, minus pi y to the fifth over 5, 0 to k. It's going to equal half of that value, which is 19.268434. So I think I'm going to divide a pi out of both sides. Plug the k in, so we get 1/3 k third plus 2k squared plus 4k minus 1/5 k to the fifth equals 6.133333. And so now we want to solve this equation on our calculator. So we want to move everything on one side equals 0. There's no way you're solving this by hand, right? Equals 0. I'm going to graph this new equation minus x intercepts. So we can go to y, type it in, x to the third. We put x's in for the k's, divided by 3 plus 2 x squared plus 4x minus x to the fifth divided by 5 minus 6.133333 window, we're looking for it to be between 0 and 2, because that's as high as the function goes, and we just want to find the x-intercept. So we're going to graph it. Should get one answer. There it is. Now we're going to find the 0, so I can calculate 0. I want to say 0.5 to 1.5, guess 1. Ooh, it looks like it's actually supposed to be exactly 1 if we did everything perfectly. But if we're using our calculator, we should round or truncate. Truncate would be 0.999. Okay. Okay, this function, find the point of intersection. So I guess this right here. So I think we want to graph both of these on our calculator. 4x squared minus x to the third, and 18 minus 3x. And window should be, I mean, what's the x-intercept over here of this? If you set this 0, this can get 6, 0, so it gives you kind of a basic idea of where that should be. So say -1 to 7, and then, I don't know, -5 to 10. Okay, there you go. So it's right there, second calc, intersect, first curve, second curve, guess. It's saying that it's exactly 3,9. That's kind of interesting. Okay, so 3,9 is the intersection. Find the area of S. So it would be this. So I think what we'd want to do maybe is calculate the triangle and then subtract this, but we've got to find this guy's x-intercept to do that. So second calc, 0. Make sure you're doing it for the right curve. That's the curve we want. It looks like it's 1, 2, 3, 4. It looks like it's around 4. So I'm going to say 3 to 5, guess 4. It's exactly 4, 0, looks like. Okay, so my strategy for B is going to be, you can find the area under this by integrating or by doing triangle 1/2 base times height. I mean, it's a pretty clean triangle. So you could do 3 to 6 of 18 minus 3x dx, or you could do 1/2 base times height. Should be the same thing, minus 3 to 4 of 4x squared minus x cubed dx. So either way you do that, second calc. So I mean, we could test out. This should be 27/2, so it should be 13.5. Let's see if math 9, 18 minus 3x, comma x, comma 3, comma 6, 13.5, perfect. Minus math 9, 4x squared minus x to the third, comma x, comma 3, comma 4. So we get 7.916. Okay, 7.916 or 7.917 if you want to round. Part C says, find the volume of the solid when R is R. This whole thing for R is revolved around the x-axis. So I'm going to do vertical slices. They're going to be disk. I don't think I want to do shells because you'd have to solve this for x in terms of y, which is not going to happen. So we're going to do volume pi r squared dx. So the limits in the x direction are going to be 0 to 4. The radius is y top minus y bottom 0 is just y top. It's going to be 4x squared minus x cubed squared dx. That's your setup. And so then we will plug that in our calculator. Pi, math 9, parentheses, 4x squared minus x to the third, close, squared, comma, x, comma, 0, comma, 4. And we get 490.208. Round or truncated, same thing through decimal, actually. All right. Okay. Find the volume and surface area of this modified Gabriel's one. Okay. So surface area, they're just giving us the surface area. By the way, I think the idea behind this would be, I don't know, we could just go with it. I mean, I think there's another way we could do surface area. I mean, we could treat each slice, say the length of the edge be, surface area would be the area along this edge right here, which would be the circumference of each slice, which is 2 pi r, which the radius is the y value, which is 2 pi f of x. So that's the circumference, and then you multiply it times the width, dx, to get that area. I think that would give you the surface area. So this is a little, this is a little more accurate because the length of the edge would be that. That's like that length of the curve formula. But so surface area, I mean, we try both ways. We're going 1 to 100, 2 pi, the function is 1 over x. We could try this one, 1 plus, the derivative would be negative x to negative 2 would be negative 1 over x squared would be the derivative. So negative 1 over x squared dx. So we can try that. See if it gives us much of a different answer. So let's see, 2 pi, math 9, 1 over x, square root of 1 plus 1 divided by x to the fourth. Close that, comma x, comma 1, comma 100. Patiently wait. Hopefully I typed down 29.645. Now the other way I was thinking was just do 2 pi the function 1 over x dx. Let's see if that makes a difference. So 2 pi math 9 1 over x, comma 1, comma 100. Does this make a difference? A little bit, 28.935. So I guess that makes a little bit of a difference. I mean, it's pretty close. Okay, volume, I would do the disk method, pi r squared dx. And so the limits are going to be 1 to 100. The radius is just the y value, which is 1 over x squared dx. So let's plug that in. Pi, math 9, 1 over x squared, comma x, comma 1, comma 100. And we get 3.110. So that's your volume. All right. Okay. Find the values of x star. So that would be mean value theorem. And so we want to find the average value first. It's the area under the curve from 1 to pi divided by 1 over pi minus 1. So we can find the average value that way. 1 divided by parentheses pi minus 1 close math 9 e to the negative x close sine x close comma x comma 1 comma pi. Let's see what we get. Okay, so we get 0.128768630. I need more than 3 decimals because I'm going to use this for another part of the problem. So now we're going to set the original function equal to the average value and solve it. Now the best way to solve it is move everything on one side equal to 0, graph it on your graphing calculator, and find the x-intercepts. So I'm going to do that on my graphing calculator. So I'm going to go to y. I'm going to do e to the negative x sine x minus 0.128768630. I'm going to go to window. I expect it to be between 1 and pi. And I just want to see the x-intercepts, -1 and 1. We're guaranteed to at least get one value. We could get more. It looks like it's right there. So second trace, 0. Looks like it is between 1 and pi. So 1.5 and 2.5, guess 2. And we get x star, which is like the c value, equals 1.968. 968. Okay, region R is enclosed by this, and this. It might be good to draw a graph. X equals 2, y equals 0. This graph, when you plug 0 into it, you get 0. When you plug 1 into it, you get -1. And when you plug 2 into it, you get undefined. So I think the graph is kind of like doing something like this. And then it's probably, as x goes to infinity, it does go to 0. So it might do something like that. If R is the area of 1, R is a region enclosed by, okay, x equals 2 to x equals k. So this region right here, and the values are, so we'd integrate 2 to k of x over x squared minus 2 dx and set it equal to 1. So then we would have to integrate this by hand, x squared minus 2 du equals 2x dx. I don't want the 2. So this is going to be 1/2 du over u. It's going to be 1/2 natural log of the absolute value of u. It's going to be 1/2 natural log of the absolute value of x squared minus 2 from 2 to k equals 1. It's going to be 1/2 natural log of the absolute value of k squared minus 2 minus 1/2 natural log of the absolute value of 2 equals 1. And then we want to solve this equation. So I'd move everything to one side and graph it on my graphing calculator and find its x-intercepts. I'm going to go ahead and stop the video here because I might run out of space, but you finish it up.